All right, so this is a follow-up to the last lesson. I didn't have you write thermochemical equations, we just did calculations that involve phase changes. I introduced you to what a thermochemical equation was. In this one, we're going to actually write thermochemical equations. And then the next one we do after this will be what happens when you go through phase changes from a different temperature of one phase to a different temperature of another phase. So we get into more mathematics. So we did a little mathematics last time. We're not going to do any mathematics this time outside of just writing numerical figures with our equations. And then the next one will be much more intensive mathematics. Giving you a little heads up on that. So the topic today is equations of phase changes, which is what you are going to be writing. Now, again, water is the most common substance on the face of the earth, and so we're pretty familiar with how it works. So I've put up here the 6 phases. I think I did that in the last one, but I put it in a more concise way so that you can hopefully follow it. Now, you're going to be doing problems in which you're going to be asked to come up with these equations. You're going to have to remember the terms like fusion and, of course, you know, freezing, but sublimation and the last one we have here, which is deposition. You're going to have to know what those phases mean. This will not be available for the test, but you should have a pretty good idea for at least half, and hopefully the other half you get down pretty well. So let's go through these fairly quickly. Fusion, as we talked about, is the same thing as melting. They don't use heat of melting, they use heat of fusion. So we're going from a solid to a liquid, melting, and that's your heat of fusion, and it is endothermic because it has absorbed heat for the solid to become a liquid. So the exact opposite of that is freezing, which I need to put on there a negative sign, because that is an exothermic reaction, exactly the opposite of this right here. So heat of freezing is going from liquid to solid. Then as we go to the next one here, we're going from a gas to a liquid, so it's going to be creating some condensation on there, and that is exactly what that means. Delta H of condensation is an exothermic reaction. Heat is being released in that process. H2O liquid to gas, that's evaporating, but we don't use the word evaporating, we use vaporization. We talked about that in the last video. And then the two that are probably not known very well are H2O solid to H2O gas, going strictly from a solid to a gas. The heat of sublimation for this particular process is 3010 kilojoules per mole. Sublimation simply bypasses the liquid part. You don't see a liquid appear, it goes straight from liquid or solid to gas. Carbon dioxide in solid form is called dry ice. If you've ever seen that warm up, you notice that it creates no liquid. It goes straight to gaseous form, which is why they call it dry ice. No liquid is produced. And the last one here is H2O gas, H2O solid. Is exactly opposite of this over here. That means heat of deposition. When you go straight from gas to solid, again, no liquid involved. That's what happens. Now, I thought what you're going to be doing here is you're going to be asked to come up with equations for substances that are not water. So let's talk about the carbon dioxide that I was talking about here. We know that carbon dioxide gas, or solid rather, goes straight to gas. So we put CO2 solid yields CO2 gas. And we know that that process is sublimation. And so delta H for this is going to be whatever they give you for that value. Now I don't have the value handy, but I do know that it's positive, and we're going to put a prefix of SUB for sublimation. And so whatever value I give you, that's what you'll be putting in here. And so the practice problems that you're going to be dealing with will give you the substance that is going to go through the change. It's going to describe the change, and you're going to sit there and write down the phase change equation with the value of the delta H that I give you in the practice problems. Okay? So I put a little more stuff into the script, into your notes, that are kind of dovetailed into what we did yesterday. In fact, some of it repeats it. But the practice problem should be fairly easy to do. So go to the bottom part of your Google Doc and find that out. Okay? Have fun.